Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to wiring the PLC S7-200 CPU SR20 with the expansion module DR08. Okay, so before we can test with the program, basically we must know how to wiring the connection of terminal of the PLC. I mean that connect from input to push button or output to the relay control. Yes, so we might understand about how to wiring. The first time we need to learn about how to wiring first before we create the program. Then I will explain about how to wiring this module with the CPU. Yes, so if we use the EMDR08, we have H10 more for digital output. It means that DR08 digital output 8 channel or 8 bits. And for the CPU, we have also 8 bits for digital output. Then we add 8 bit more, so totally 16 bits for digital output. And for the digital input, we have 11. Yes, we have 12. Yes, from I0.0 to I1.3. Yes, and for the address, it will start from Q0.1 until Q0.7, 8 bits. And for this one, it will start from Q8.0 until Q8.7, 8 bit also. Okay, I will detail when we create the hardware configuration for this CPU on the step 7 MicroWin Smart, and we will create the sample HMI on the TIA Portal version 17 to test and simulation with this PLC. Okay, so I will connect the real PLC to the PC via Profinet port of the PLC to the PC, and then I will simulation from the PC by using the TIA Portal version 17 for the HMI. Okay, then I will detail more about how to wiring this terminal. Yes, so let's go. Okay, right now this just example. I have push button start and stop. Yes, that start button and stop button I will connect to the input I0.0 for start and I0.1 for stop. And if we supply 220 AC to the PLC, we will got 24 voltage from here. Yes, then we can connect to supply. Yes, first we need to supply the expansion module, yeah, DR08. So I will connect L plus to L plus of the EM module, and then M to M of EM DR08 module. Okay, and for the digital output, we can connect directly from the 220 volt to directly to the relay. Yes, so this relay is 220 for magnetics. Yes, then this one I also connect with the 220 volt AC. Yes, then this one will start from Q0.0 and this one will start from Q8.0. Okay, so input is 24 voltage, and for the output we can use both 24 and 220 AC. Okay, so it is the dry contact for this one and this one. Then we can select both, or we can connect both 24 volt DC or 220 AC. Okay, so if we would like to connect with other relay to control the motor or electrical devices, we can use 8 bits more. Yes, so we can jumping between this one and this one. Then we can use this contact to control the some electrical devices that we want. Okay, so this is just overview about how to wiring the PLC SIMATIC S7-200 Smart CPU SR20 with the expansion module DR08. Okay, then we can go to create the sample program or sample project test with the HMI for simulation. Okay, so let's go. Okay, so first we need to open the step 7 MicroWin Smart and DR08 Portal version 17. So I will open the SIMATIC step 7 Smart version. Yes. And first we need to create the hardware configuration. Yes, so let's go to hardware configuration, double click, and then choose the CPU type that match with our hardware. So right now I will use SR20. Yes, CPU SR20, and then I will add the battery. Yes, and then I will add the DR expansion DR08 here. It means that 8DO or 8DQ relays. So let's click, and then the address will generate automatically. Let's see, the input start from I0.0 and output of the CPU it will start from Q0.0. Okay, and for the expansion module it will start from Q8.0 until Q8.7, right? So totally 8 bits, and this one 8 bits also. Then we can use for 16 bits for this project. Okay, and then we can go to the CPU setting and then go to startup. It's very important here. So for the startup mode we can select 3 options that we can select. The first one is stop, the second one is run, and the third one is last. And I would like to explain the same as the previous lesson. For the stop mode, if we select like this, when we turn off and turn on the power back, the PLC will not run. Okay, and we choose the run mode. When we turn off and turn on the power again, the CPU will start automatically. Okay, and for the last, it means that when we select last like this, it means that it will remember the last state of the CPU before we turn off the power, and then after we turn on the power again, it will remember the last state of the CPU. So when the last state of the CPU is run, it will run. When the last state of the CPU was stopped, it will stop. Okay, so I recommend to use run, because at the local side we no need to restart the CPU. Example, when the electricity was cut, then we can turn on again, the CPU will running. Okay, so good. I will select run, and then we can create the sample program for test the digital output or expansion that we already created here. Yes, so basically we can write m0.0, or we can write i0.0. it is the stop button, right? Sorry, start button here. And then we can choose the stop button i0.1, and then we can choose the output. So q0.0, it is the CPU output right here. This relay will turn on, and then I will hold the signal by q0.0. Yes. So when we write a program like this, we can use only push button start and stop. Okay. But if we would like to start and stop from the HMI, we can also add more for start and stop. Okay. So I will insert the column and then insert the new button. So example m0.0, it is the stop, or m0.1, it is the stop. So stop from HMI. Yes, stop from HMI. And then if we would like to start from HMI, okay, I will insert column NO, start from HMI, right? So m0.0. Yes. So we can start from the HMI, and then this signal will hold, right? This signal will hold. So in this case, I will parallel. So I will insert the row and then pay this one. Yes, like this. And then we can save the project. Yes, I will insert a new folder for this project. So S7-200 smart DR08 EM DR08. Yes, so DR08 smart, and then we can download to the PLC, right? But before download, we can go to communication to check the communication, and then please find the CPU. It will detect the CPU, because right now I already connected the LAN cable from my PC to the Profinet port of PLC. So right now it detects one CPU that has IP address 192.168.0.20, and then please OK, and then we can download. So push download to download the program to the CPU, and then we can online to check. Yes, so this one it is the false signal that from the last video, yes, that we already learned, right? So I will unforce all. Okay, and then I will stop. I will stop the relay first. Okay, and then we can go to create the HMI for test the case. Yeah, so let's go to TAA portal. Then create the new project. I will put DR08 smart project, and then browse to find the folder that we already created on desktop. So I will choose this one, yes, and then click create to create the project of HMI. And then go to project view to create the new HMI. Yes, go to add new device, double click, and then go to the HMI item and go to select the HMI that we want to use. Right now we use the TP700 comfort HMI. Yes, then we can click finish. Okay, I will delete this one first. Okay, delete. Okay, so first we need to create the connection. Yes, I will add the new connection, example PLC Smart 200, and then I will choose S7-200 here. We have many drivers that we can use to connect with the PLC or OPC-UA or Modbus RTU, Modbus TCP/IP. Yes, so many driver that we can use. Right now I will use S7-200 smart and then choose the Ethernet, and I will check my IP address. So IP config, so 192.168.0.253, and the PLC address is 192.168.0.20. Yes, Then we can save the project, and then we can go to create the tag, right? So double click, show all tag, and then create the new tag, right? The first one is M0.0 for start M1. So the data type is boolean, and then I will use the PLC, right? Okay, and the address will start from M0.0, and I will change this one to 100 millisecond. And then we need to create the push button stop, right? This one. So this one M0.1, right? M0.1. We can rename, yes. This one should be start from HMI. Okay, M0.1 stop from HMI. So stop M1 stop from HMI, right? Address is M0.1. Then I will change to 100 millisecond. And we need to create the motor status, right? So I will use Q0.0 motor 1 status. I will change to Q0.0 100 millisecond. Okay, then we can go to save and then compile the HMI. Should be no error, right? Because we not yet configure any option. Yes, so I will change the background to be the same as the previous lesson. I will use this color. Yes, I like this color. So we can use another color that we want. So the first I will create or insert the motor. Yeah, we do this motor. And I will use the button. Stop M1. Then we can copy and paste. Start M1. Okay. For the faceplate, I already explained and show and share in the previous video. So in this lesson, we no need to create the faceplate again. Yes. We just put the normal condition for start and stop the motor. Okay. Then I will insert the rectangle and then choose with the send to back. Yes, send to back. Okay, I will adjust this one a little bit. Okay, like this. And I will put the rectangle one more. Okay, for the stator of mirrors. Then I will adjust to be center like this. Okay, I will change the background to be this color. Yeah, we can use another color that we want. Okay, then I will change this color of button to start. Okay, and then change the color button stop to be red color. Yes, and for the text button I will use black. This one also I will use black. Yes, and for the chamfer, yes, we can also adjust here. Zero, it means that we no need to put the cover. Yes, and then this one I will change color to be red, the normal status. It means that motor stop. Okay, I will change the background to be this color. Yes, and then I will put the title with motor 1. And check the fit, and then we can adjust. And then I will alignment to be center and adjust the size. Yes, for motor 1. I will simulation the screen a little bit to check to confirm the screen that we created is okay. Okay, good. I will adjust this one a little bit more. Yes, like this. Yes. After that, we can show the status of the motor. Yes. So we insert the text, copy the text, and then paste. So when motor running, I will put running. Running status, and then I will use the fill to this color. Property, go to apparent, and then solid. Yes, we can show the running status when motor is run, right? Okay, like this. And then we need to configure the push button start and stop, right? So for button start, we can go to events, go to click, go to freeze, and set bit val key freeze, right? And then go to take default. I will choose drag and drop the start M1 to the events function. And for the stop also we can do freeze, set bit val key freeze, and then choose the stop M1. Yes. And for the condition, we can right click and then go to animation, go to display, add new animation, choose the apparent, and then choose the motor 1 status, and add the new. When the condition 1, it means that turn on, it will show green. Yes. And for this one, we can also choose the new animation and choose so we need to visible this one. Yes, we pop up when the motor is running. Yes, so we can go to drag and drop the motor status here, and then choose rank from 0 to 0, and then choose invisible. Okay, then we can save and we can simulation for test. I will compile the project first. Okay, there is no error occur. Then we can simulation. Yes, and then we can go to test together with the SIMATIC Step 7 Smart software. So when I push start, let's see, the relay is turned on, then the signal motor running is pop up. Okay, when I push stop, it will stop. Start again, it will start again. And I will show the relay status when I push start and stop. Okay, so relay is running right now. So if I push stop, yes, it works. When I push start, yes, it works. And then we need to create the program for test with the EM DR08, right? I will use the Q8.0, yes, connect to another relay. So I will outline first. And then I will start from network number 2. So I will insert the push button, start M2, M0.2, stop M2, M0.3, and I will hold the signal. So this one should be 8.0, right? Q8.0. It is the EM. Yeah, this one. We connect from this EM terminal. Then I will hold signal by Q8.0. Yes. So this one start M2 from HMI, and this one stop. We can write stop M2 from HMI. Yes. And then we can save the project, and then we can download to the PLC. Yes. And we can online to see the status. Yes. So we need to create text in the GIA portal, right? For start and stop command from the HMI. So let's go to text. And then I will copy and paste. So this one should be start M2. This one should be stop M2. And this one should be M2 status. So I will change address to be M0.2, and this one M0.3, and this one should be 8.0, right? Okay. And then we can save and go back to the root screen. And it's very easy. We can copy the platform here. No need to create again. Just copy and paste. Select again. Right click, copy, right click and paste. And we can add one more, paste. We will got 3 motors. Yeah. We got 3 motors. So this one motor 2, this one motor 3, and then I will go to create more program. So this one start from M0.3, right? So I will start from M0.4, M0.5, and example I will use Q8.1. It is the EM also, right? And I will hold it now by Q8.1. Yes. So start M3 from HMI, and this one stop M3 from HMI. Yes. Then we can save the project, then we can download again. Okay, start the CPU, and we can online to check. Yes. So I will create M0.4 for start command of model M3. Basically we can copy here, copy and paste, change this one to M3, change this one to M3, change this one to M3 also. So this one M0.3, sorry, 0.4, and this one M0.5, and this one Q0.1. Yes. Okay, good. Then we can go back to root screen to design and configure the push button and another graphic. So I will adjust the align a little bit. Okay, like this. Okay. So model number 2, we can go to events and then change this one to be stop number 2, and then this one events start model M2, and for the status go to visibility M2, and this one status go to apparent and change this one to M2. Okay, and for model M3 we can go to stop M3, or this one should be changed to M2, change to M3, this one should be M3, this one should be M3 also. Yes. Then we can go to events, change this one to stop M3, change this one to start M3, change this one color animation visibility, and change this one to be M3 also. Yes. So finish. Then the content here we can also insert. We change the color to be, go to property and change the color to be this color, and then I will choose the text. Basically we can copy from here and paste. TIA Portal version 17, create the button, create the screen for control motors, and then I will change the font size to be 1525, and then change the color to be yellow. Okay, we can save and then go to simulation. Okay, and then we can go to see the status. Yes, when I start motor M1, yes, let's see. When I start motor M2, in M2 start running, and when I start motor M3, yes, M3 will run also. Yes, so I will show the status on the PLC. Let's see, the PLC is turned on the output, both the CPU and EM, right? So if I push stop the EM first, yeah, relay turn off, pull out this one, yes, and stop this one also, yes, start again, yes, so it worked perfectly. So this is just example about how to wiring the PLC S7-200 Smart CPU SR20 with the EM DR08 that has 8 bits of digital output, and we can create the TIA portal screen to test, yes, stop and start the relay control for the control the motor. If we would like to control the motors or some electrical devices, we can connect from the relay control, and then the process will working perfectly. Okay, so thank you very much for watching my video. If everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye.